Welcome back, tech enthusiasts. Today we're diving deep into Azure Repos, a powerful version control system in Azure DevOps. By the end of this video, you'll learn what Azure Repos is, how to create a new repository, how to set up repository policies, how to enforce branch policies to maintain high code quality, how to manage permissions to secure and streamline your development workflow. Let's get started. What is Azure Repos? Azure Repos is a cloud-based version control system that helps teams manage their source code efficiently. It supports Git, a distributed version control system which is most commonly used. Then TFVC, Team Foundation Version Control, a centralized version control system. Most developers use Git because it offers branching, merging, and collaboration flexibility. Azure Repos makes it easy to store, track, and manage code changes across teams. For example, imagine a development team working on a web app. With Azure Repos, they can track code changes, collaborate with team members, and ensure code quality using policies. Let's now create a new Git repository in Azure Repos. Go to Azure DevOps. Select your project. Go to the repos. Select New Repository. In the Create a New Repository dialog, verify that Git is the repository type and enter a name for your new repository. You can also add a README and create a .gitignore for the type of code you plan to manage in the repo. I am managing Visual Studio. A README contains information about the code in your repo. The .gitignore file tells Git which types of files to ignore, such as temporary build files from your development environment. When you're happy with the repo name and choices, select Create. A new empty Git repo is now created in your project. Now let's clone the repo and try to make some changes to understand how we can clone, push, or commit changes using Git. Select Clone in the upper right corner of the Files window and copy the clone URL. Open the Git command window. Git bash on Git for Windows. Then, browse to the folder where you want the code from the repo stored on your computer. Run git clone followed by the path copied from the clone URL. Git downloads a copy of the code into a new folder for you to work with. The download includes all commits and branches from the repo. Switch your directory to the repository that you cloned. Run command cd learning repo. Keep this command window open because you use it in the following steps. Now let's make a change to the files on our computer, commit the changes locally, push the commit up to the repo on the server, and view the changes there. Browse to the folder on your computer where you cloned the repo and open the readme.md file in your editor of choice. Make some changes. For example, add, "This is my first edit to the file," and save and close the file. In the Git command window, check Status. Run command git status. You will see README file in red color. That means we made some changes in it. First, let's add the changes. Then let's commit it. When you use git commit, M specifies a commit message. Push your changes up to the Git repo by entering git push command into the Git command window. Switch back to the web portal and select History from the code view to view your new commit. The new repo has two commits. The first is the commit where the README and .gitignore were added when the repo was created. The second is the commit you just made. Now let's learn about how to set up branch policies. To understand all policies, you will have to create another branch than master or main, because all these policies will apply for the pull request when you will merge your code from feature branch to the main branch. Click on the repo that we created. Select Manage Repositories. You will get all your repos in your project. Select the repo where you want to set policies. Go to the Policies section. First, you will see Repository Policies contains policies related to the repository. On the bottom, you will see Branch Policies. Today we will learn about branch policies, so select on that. Let's understand all policies one by one. First is require a minimum number of reviewers. Enable it. Enter the required number of reviewers. Let's enter 1 as required reviewer. Let's make some changes in the README file. Commit the changes and push it to the repo. You will see it says you updated branch. Now let's create pull request from your feature branch to main branch. Give the title and create it. It says at least one reviewer must approve as we set branch policies. Otherwise, you can't complete pull request. Let's add one reviewer. Learn 903 is mine user ID, so I can't approve my pull request. So let me add another user. So when this user will approve it, then only you can complete pull request. That another user has approved it, and you can see condition has met. Now let's complete the pull request by clicking on Complete button. Oops! I mistakenly delete the feature branch as well. No worries, we will create it again. Now it is completed. Now let's learn next policy. Allow requesters to approve their own changes to allow a PR's creator to approve it. Let's make changes again to the README file and commit it and push it to the repo. Create a pull request. It shows one reviewer must approve. In this policy, I add my user ID and approve it. Let me click on Approve button and condition met. Next policy is prohibit the most recent pusher from approving their own changes. Selecting this option means the most recent pusher's approval doesn't count, even if they can ordinarily approve their own changes. Let's make some changes again to the README file and commit it and push it to the repo. Create a pull request. Or go to the Pull Request section and view pull request. It says, at least one reviewer besides author, that means the user who pushed the code must approve. Even if I approve it, condition won't satisfy. Because I am the pusher. You have to add your manager or colleague to approve it. Next policy is allow completion even if some reviewers ask to wait or reject to allow PR completion, even if some reviewers don't approve. The minimum number of reviewers must still approve. Next is for when we push new changes. Under that we have some policies. First is require at least one approval on every iteration to require at least one approval for the last source branch change, meaning latest push. The user's approval isn't counted against any previous unapproved iteration pushed by that user. As a result, another approval on the last iteration is required to be done by another user. Second is select require at least one approval on the last iteration to require at least one approval for the last source branch change. Third is reset all approval votes, does not reset votes to reject or wait, to remove all approval votes, but keep votes to reject or wait whenever the source branch changes. Fourth is reset all code reviewer votes to remove all reviewer votes whenever the source branch changes, including votes to approve, reject, or wait. Then next and most important policy is check for linked work items. Linking work items provides more context for changes and ensures that updates go through your work item tracking process. This setting requires that work items be linked to a PR for the PR to merge. Let's make some changes again to the README file and commit it. This time I have made changes directly to the repo. I am assuming as of now you are familiar with how we can use Git command to push and commit code. Create a pull request. It says work items must be linked, so we have to associate work item with this PR. You can add work item at the time of commit from the repo or from the pull request page. Let's add from pull request page for now. Add a work item from right-hand side. Click plus button and select related work item. I already uploaded separate video on Azure Boards. Please check it out. So now conditions satisfy and we can complete the PR. Next policy is check for comment resolution. The check for comment resolution policy checks whether all PR comments are resolved. For example, if in one of my active PR, someone has added comment, then I can't compare PR until that comment has resolved. Let me add some comment. It failed to complete checks. It won't allow to complete PR until I resolve this comment. Let me resolve the comment. Now see, I can complete the PR. Next policy is limit merge types. Azure Repos has several merge strategies, and by default, all of them are allowed. You can maintain a consistent branch history by enforcing a merge strategy for PR completion. Let me give you a short overview on it. Basic merge, no fast forward, creates a merge commit in the target whose parents are the target and source branches. Squash merge creates a linear history with a single commit in the target branch with the changes from the source branch. Rebase and fast forward creates a linear history by replaying source commits onto the target branch with no merge commit. Rebase with merge commit replays the source commits onto the target and also creates a merge commit. Let's see it with example. Make some changes to README file and commit it. Or go to your active PR. Click on Complete button. You will see Merge Type dropdown. You will see all merge type there. Now let's disable some of them. Got back to the PR, you will see only we enabled it. Next policy is build validation. You can set a policy requiring PR changes to build successfully before the PR can complete. Build policies reduce breaks and keep your test results passing. Build policies help even if you're using continuous integration CI on your development branches to catch problems early. A build validation policy queues a new build when a new PR is created or changes are pushed to an existing PR that targets the branch. The build policy evaluates the build results to determine whether the PR can be completed. Let's set up build validation. I am using another repo because I have build pipeline created on it. Click on plus, select build pipeline name. Set trigger as automatic, which will trigger whenever the source branch is updated. You can set manual as well. Under policy requirement, select required or optional. If you choose required, builds must complete successfully to complete PRs. Choose optional to provide a notification of the build failure but still allow PRs to complete. Set a build expiration to make sure updates to your protected branch don't break changes for open PRs. You can select immediately when master is updated or after some hours if branch has been updated or never. I would select 2 hours, which expires the current policy status when the protected branch updates if the passing build is older than the threshold you enter. Save it. To validate this, make some changes to the file and commit it. Create pull request. Let's try to complete PR. It says build queued. You can see build pipeline is running. Let's wait until it completes. So that means by doing this you can catch conflicts in advance before go the CI stage. Build is completed. Now click on Complete to complete PR. You should be able to complete PR. Next is Status Check. External services can use the PR Status API to post detailed status to your PRs. The branch policy for additional services enables those external services to participate in the PR workflow and establish policy requirements. To verify this policy, let's make some changes again and commit it. Go to the policy page and click on Plus to set up Status Check. Select Policy Requirement as required. That means status is succeeded needed to complete pull requests. Select any identity can post this status, or select some particular one. Save it. And you will see one check is required. So you won't be able to complete this PR until third party will not post status on your PR. Next policy is automatically include code reviewers. You can automatically add reviewers to pull requests that change files in specific directories and files, or to all pull requests in a repo. To set up this policy, click on Plus. Add reviewer name that you want that person must approve PR or any changes. Specify the files and folders that require the automatically included reviewers. Leave this field blank to require the reviewers for all pull requests in the branch. Select Allow requesters to approve their own changes if pull request owners can vote to approve their own pull requests to satisfy this policy. Save it. To validate this policy, make some changes to the repo file. Commit it. Create pull request. You will see user has already added to the PR. If you remember, for the previous PR, we had to add it manually. I added myself, so let me approve it and complete PR. It is completed now. Now let's talk about branch security. Set up permissions to control who can read and update the code in a branch on your Git repo. You can set permissions for individual users and groups, and inherit and override permissions as needed from your repo permissions. Go to the branches. Click on the branch where you want to set security. Click on 3 dot and select Branch Security. Here you can set permissions. You can add or remove individual user or a group to whom you want to give access, or what level of access you want to give to the user or group of the user. Moving further, let's learn how we can delete branch and how to restore deleted branch. Go the branches. Click on the branch which you want to delete. Click on 3 dots. Click on Delete Branch. Hit Delete, and now it's gone. Now let's restore this delete branch. Search for the exact branch name using the Search All Branches box in the upper right. Select the link to search for exact match in deleted branches. If there's a deleted branch that matches your search, you can find which commit it pointed to when upon deletion, who deleted it, and when. You will get your deleted branch. Click on 3 dot and select Restore Branch. Your branch is back. If you reuse the same branch name for different commits, you might not see all the commits you're expecting when you restore the deleted branch. In that case, go to the Pushes page of the restored branch to see the entire history of the branch. In my case, I didn't lose any commit. But you have lost it, you can go to a specific commit, then select New Branch from the 3 dot. From there, you can use a pull request, cherry pick, or merge to get the commits back into the desired branch. That's a wrap. Today we covered what is Azure Repos, how to create a repository, branch policies to ensure high-quality code, managing permissions for secure collaboration, delete branch and restore branch. If you found this helpful, hit that like button and subscribe for more DevOps content. Turn on notifications so you never miss an update.